Today we're going to look at sum and difference formulas. What you'll need are this list of sum and difference formulas. What you may want to do is take a moment to pause the video and write down all of these. We'll be referencing them as we go. And you'll also want a unit circle handy. So I've got one just off to the side here, and I'll be bringing that back over as needed. All right, so sum and difference formulas are used when we need to find the exact value of some degree measurement, whether that's in degrees or whether that's in radians, some angle. And what we can do is say, for example, 75 degrees doesn't appear on my unit circle. So normally I'd be like, I can't use my unit circle to find what this measurement is. However, I know that I can make 75 degrees by going 45 plus 30. 45 plus 30 is 75. How can I use this information to help me out? Well, as it turns out, with the sum and difference formulas, I'm finding the cosine of 75 degrees, or rather, I'm finding the cosine of 45 degrees plus 30 degrees, since 45 plus 30 is 75, I can use one of these formulas. Here, this will be the cosine of u plus v, where u is going to be 45 and v is going to be 30. Let's go ahead and write this down. So I've got the cosine of 45 degrees plus 30 degrees. This is going to be equal to the cosine of, remember, u represents 45 here, times the cosine of 30 degrees, minus the sine of u, so the sine of 45 degrees, times the sine of 30 degrees. All right, now what I want to do is I want to bring my unit circle over here. And I say, I want the cosine of 45 times the cosine of 30. So I find 45 degrees and 30 degrees. Cosine of 45 is square root of 2 over 2. And 30 degrees, cosine of that, is square root of 3 over 2. And then I'm going to subtract sine of 45 is square root of 2 over 2. And times the sine of 30 degrees, that'll be 1/2. Okay, so 45, 30, cosines there, square root of 2 over 2 times square root of 3 over 2 minus sine of 45 times sine of 30. So that'll be minus square root of 2 over 2 times 1/2. Let's write that down. So we've got this is going to be equal to square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. All right, square root of 2 times square root of 3, that'll just be square root of 6 over 2 times 2 is 4, minus square root of 2 times 1 is square root of 2, over 2 times 2 is 4. These fractions are the same denominator, so I'm going to go ahead and subtract them. This is going to be the square root of 6 minus the square root of 2 over 4. Let's do another one. This time we're using radian measures. Find the exact value of sine of pi over 12. Okay, so let's bring our unit circle over. And I notice that pi over 12 is not on the unit circle. So again, normally I'd look at this and go, I can't find that. However, with the sum and difference formulas, I'm going to find a way to make pi pi over 12? Well, let's see. Pi over 3 is the same as 4 pi over 12 if I were to multiply the top and the bottom by 4. And pi over 4 is the same as 3 pi over 12 if I were to multiply the top and bottom by 3. So what I could do is say pi over 3 minus pi over 4 would be the same as 4 pi over 12 minus 3 pi over 12, making a single pi over 12. Okay, so that's the way I'm going to do this. Let's write that down before I forget that. So I'm going to do the sine of pi over 12, which is really going to be the sine of pi over 3 minus pi over 4. All right, now that I've got that as a reminder, let's do this over here. That's going to be the sine of pi over 3 minus pi over 4 equals, okay, so this is going to be the sine of u minus v. Let's bring over my formula list. Sine of u minus v is the sine of u times the cosine of v minus the cosine of u times the sine of v. Okay, so that'll be sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 times sine of pi over 4. All right, sine of pi over 3 times the cosine of pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. Well, let's bring the unit circle over now. Pi over 3 and pi over 4 are right here. The cosine of pi over 3 and cosine of pi over 4 are 1/2 and square root of 2 over 2, respectively. And the sines are square root of 3 over 2 and square root of 2 over 2, respectively. So I'm going to go ahead and fill those in here. All right, this will be the square root of 3 over 2 times square root of 2 over 2 minus 1/2 times the square root of 2 over 2. Okay, so this will be square root of 3 times square root of 2, so that's square root of 6. Over 2 times 2 is 4, minus 1 times the square root of 2, so that'll be the square root of 2. Over again, 2 times 2 is 4. Interestingly, this is the exact same answer as we got before. So this is going to be the square root of 6 minus the square root of 2 all over 4. Okay, let's do one last one, this time with a tangent. Find the exact value of tangent of 11 pi over 12. So again, when I bring my unit circle over, 11 pi over 12 isn't on here. But is there a way that I can make that? Let's see. 12. So 2 pi over 3, I multiply that by 4 over 4. That will give me 8 pi over 12. And then pi over 4, I multiply that by 3 over 3. That'll give me 3 pi over 12. So this will be 8 plus 3 is going to make 11. So I'm going to do tangent of u plus v, where u is 2 pi over 3 and v is pi over 4 in order to get me to 11 pi over 12. So I want the tangent of 2 pi over 3 plus pi over 4. So u plus v. Let's bring over my formula sheet. Tangent of u plus v is going to be equal to tangent of u plus tangent of v. So that'll be tangent of 2 pi over 3 plus tangent of pi over 4 all over 1 minus tangent of 2 pi over 3 times tangent of pi over 4. Okay, so this one plus this one all over 1 minus this one times this one. So I've got tangent of 2 pi over 3 plus tangent of pi over 4 all over 1 minus tangent of 2 pi over 3 times the tangent of pi over 4. Okay, let's bring my unit circle over. Tangent of 2 pi over 3 is negative square root of 3, and the tangent of pi over 4 is 1. So every time I see tangent of 2 pi over 3, I'll replace that with negative square root of 3. Every time I see tangent of pi over 4, I replace that with 1. So this is going to be negative square root of 3 plus 1 all over 1 minus, these two are going to get multiplied together, negative square root of 3 times 1. Okay, so this is really negative square root of 3 plus 1 all over 1 plus square root of 3. Since negative square root of 3 times 1 is going to be negative square root of 3, but then if I'm subtracting negative square root of 3, I can just change that to a plus sign there. Let's space this out a little bit better. All right, now depending on your teacher or professor, they may accept this answer as it is. However, some may want you to go one step further and rationalize the denominator. So to do that, I've got 1 plus the square root of 3. I'm going to multiply by the conjugate. So what that means is I need to multiply the top and the bottom by 1 minus the square root of 3. Okay, so really that's going to be multiplying the top parts together and multiplying the bottom parts together. I'm going to do 2 boxes. So let's do the top box right here. So this will be negative square root of 3 plus 1. I could also write that as 1 and then minus square root of 3 to make that look a little nicer. And then 1 plus the square root of 3 here. Oh no, 1 minus another square root of 3 here. So this will be 1 minus square root of 3 and then 1 minus square root of 3. There we go. Okay, so this will be 1, then negative square root of 3, negative square root of 3 here, then negative times a negative is going to be a positive. Square root of 3 times square root of 3 is just going to be 3. Let's combine like terms. This is going to be 1 minus 2 square root of 3's, and then plus another 3. So this ends up being 4 minus 2 square root of 3. Okay, what about the bottom part? Okay, for the bottom part, I'll have 1 plus the square root of 3. And then times 1 minus square root of 3. So this will be 1. Then we've got negative square root of 3 here. Positive square root of 3. And then negative times a positive. So that's going to be a negative, and then square root of 3 times square root of 3 is 3. So this will be negative 3 here. Now, when I go to combine like terms for this, I've got a positive square root of 3 and a negative square root of 3. So those will subtract out, leaving just 1 minus 3, or negative 2. Okay, so then the top part ends up being 4 minus 2 square root of 3 over the bottom part is a negative 2. And what I can do with this is I can say this 4 and this 2, they both have a 2 that I can factor out. More specifically, I can factor out a negative 2 to the front. So if I factor out a negative 2, then what I'll have left over is 4 divided by negative 2 is negative 2. And negative 2 square root of 3 divided by negative 2 will be just plus square root of 3 here over this negative 2 on the bottom. And then we can divide these out. Final answer, negative 2 plus the square root of 3. All right, that is sum and difference formulas.